In this video, we're going to make a heat map to help display information to the player. We're going to expand upon the grid map we made in the previous video and use a custom mesh to dynamically update our heat map. Let's begin! Hello and welcome, I'm your Code Monkey, and this channel is all about helping you learn how to make your own games with in-depth tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. Okay, so here we are, and this is what we want to make. We have a nice scene here, and it looks like it's completely empty and just with a black texture. However, when I click on the mouse, yep, there it is, I placed something which modified the underlying grid and the visual display. So I can click with the mouse button in order to impact the underlying grid, which then impacts the visual, and as you can see, the visual where it's clicked, it's red, and as it gets towards the edges, it becomes red, and where the value is 0, it becomes black. So the color is smoothly interpolated based on whatever value is underneath. Now I have enabled debug visual so we can see the underlying shape and values of the grid, and you can see that when I click, the values change and the visual also changes. So right down the middle, you can see that it has 100, which is the maximum value, and as it gets towards the edges, it continually goes down until it reaches 0. An example of something like this used in a complete game is the park environment system in Battle Royale Tycoon. In the game, you can place objects to improve the park environment, and each of them has a radius and an effect they cause. So when I place an object, the environment updates and increases the underlying value in a nice diamond pattern. So this is an example of a system like this being used in a final game. Alright, so this is our goal. Let's get to it. Okay, so here we are in our scene where we have just a simple background texture. Also in here on the scripts folder, I have the grid class that we created in the previous grid map video. If you haven't seen that one yet, there's a link in the description. In that video, we go through the creation of the grid class, which we are now going to use as a base to create our heat map. The grid class is already based on ints, which is exactly what we want to use here, so making this effect should be relatively simple. So let's first start off by making sure our grid class works. So we're going to create a new script, let's call it testing. And here, make a new game object, call it testing, and drag the script onto it. Okay. Now in here, let's make a private void start, and in here, let's create a grid. So we do grid, make a new grid, pass in the width and the height. So let's pass in width of 20, height of 10. Now we pass in the cell size, let's say 10, and the origin, let's put it at vector 3.0. All right, so let's see what this does. And here we are, and yep, there it is, our full grid map with a width of 20 and a height of 10. Alright, awesome. We have text objects being created which show the underlying values, and using gizmos we are enabling to show the edges of each grid cell. Again, all of this was fully created from scratch in a previous video, so check that out if you haven't already. Alright, now that we can see our starting grid, let's think about what we're going to need in order to make our heat map. The first thing we want is to make sure our grid's underlying values stay inside a valid range. So let's go into our grid class. Here it is. Now we have our simple constructor, which as you can see we receive width, height, a cell size, and a origin position. Then over here we have the code to show our debug lines and text fields. And if we go all the way down here, we have our nice set value function. So it's here that we want to validate this value to make sure it stays within our valid range. So for that, let's make some constants. Go all the way up here. Make a public const int, and let's call this the heat map max value, and let's put a maximum of 100 and a public constant for our heat map min value, which will be at 0. And now we just take these and go down to the set value, and let's make sure that our value is mathf.clamp. So we're going to clamp our value between our minimum and our maximum. Alright, that should do it. So let's go back into our testing script. And in here, let's make some code to increase the underlying value on the grid whenever we click on it. So we make a simple update. In here, we test for an input, get mouse button down on the left mouse button. And when you do, let's get the mouse world position. So for that, I'm going to be using the CodeMonkey utilities, which as always you can grab for free from unitycodemonkey.com. So from that, I can use get mouse world position. Here is the function in case you want to make it yourself. All it does is a screen to world point on our world camera. So with our mouse world position, we want to increase the underlying value of the grid. So before we set the value, let's first go in the grid and get the value. So in here, we need a reference to our grid object. So we have our reference, we set it on start. In here, we use it. So we get the value, pass in the world position. All right. So this is our current value. Then we do grid.setValue, pass in the same position. And then we pass in value plus 5. So every time we click, we should be able to see the underlying value increase by 5. All right, let's test. Okay, here we are in our grid. Now, first of all, if we click outside the grid, you can see that nothing happens. In the previous video, we decided it was best to ignore invalid values in order to prevent our grid from behaving weirdly over on the edges. So if I click here, it does nothing, but if I click on top of the grid, there you go, that one went from 0 to 5, click again, 10, and now keep clicking, and let's see the maximum, and there you go, it's at 100 and can no longer go higher. Okay, awesome. All right, so now that the underlying values are working correctly, let's see how we're going to display them with some very nice colors. So that means it's time to work on our heat map visual. So in here, let's start off by making a new C# script, call it Heatmap Visual. Let's make a game object to handle it. So a new game object, call it the Heatmap Visual. Drag the script onto it, and let's make sure the object is on the origin. So 0, 0, 0. Okay. Now let's open it. And now in here, in order to display our heat map, we're going to use a custom dynamic mesh. If you want a in-depth look into how to create a dynamic mesh through code, then check the link in the description. In that video, I cover what are the elements a mesh needs and what each of them represents. It covers how to start off rendering a simple triangle, then making it into a quad and manipulating the texture. If you understand everything in that video, you'll be able to easily follow along how we're going to create the heat map visual mesh. Okay, so let's create the mesh. And for that, I have a simple mesh utils class. This has a bunch of functions for creating and adding stuff to the mesh. You can easily make this class yourself based on the knowledge of the mesh video, or you can download it from this video's project files. It just creates the various vertices, UVs, triangles, and has a bunch of functions for setting them. Again, if you're not familiar with how mesh is created through code, check out the other video linked in the description. Now, in order to render our mesh, there's still something we need on our game object in here, which is we need to add a mesh filter and also a mesh renderer. So this mesh will be created dynamically through code. And now in here, we need to add our material. So here in the project files, you can see that I have a nice gradient texture. As you can see, the first pixel is black, then it goes from red to yellow to green. So let's make a material to use it, just very simple. Make a new material. Let's use the unlit texture and drag the texture onto it. All right, there's our material, and just drag it onto our mesh renderer. All right, that's it. Now back in the code. Now here, in order to visualize our heat map, we want to display one quad per grid position. So first, we need a reference to our grid. So let's make a function, a public void, call it setGrid, and we're going to receive a grid object. Let's store it. All right, so now we need to call this function from somewhere. So for that, let's use our testing class. And here, let's add a serialized field, make it a private of type heatmapVisual. And on start, first we create our grid, and then we go into the heatmapVisual and set the grid and pass in our grid. All right, so now we just need to go into the editor. And here on the testing script, let's just drag the reference. All right, awesome. So back into the heat map code. Let's also make a awake to grab the reference to the mesh filter. So we have the reference to the mesh filter, and we need to set our mesh. So in here, let's make a mesh equals a new mesh. So this is the mesh that we're going to use and reuse. So let's actually store it up here. Just like that. All right. So all our setup is done in order to visually see our mesh. Now it's time to finally make the code in order to actually draw it. So down here, let's make a private void, and let's call it update the heat map visual. Now in here, let's first set up our arrays. Here on the mesh utils, I have a nice function which already calculates all of the vertices, UVs, and triangles with a given quad count. So let's use that. So go into the mesh utils, call create empty mesh arrays. Now for the quad count, it's very simple. We just need the grid in order to get the width multiplied by the grid.getHeight. So that's our quad count, and now let's create our arrays. Alright, so just like this, we are creating all of our local arrays with the correct size. Now down here, let's cycle through the width and the height. Alright, here we are inside our cycle, and now in here, let's first calculate the index that we are currently on. So an int for our index, and the current index will be the current x, multiplied by the grid.getHeight, and plus the current y. So with this, we have our index cycling through every single quad. So let's just do a debug.log to make sure everything is great so far. So a debug.log on our index. And in here, when we set the grid, let's call update the heatmap visual. And to make it easier, let's go in here and reduce the size to be just 10.5. All right, let's test. And here we are, and there's our smaller grid. And over here on the console, we can see our indexes are indeed going correctly. So going from 0 all the way to 49, since we have 10 by 5. All right, awesome. Now in here inside our cycle, we already have the index, and it's in here that we need to set our quad values. So for that, I have a very nice helpful function here. It's called add2meshArrays, and just takes the various arrays that make up the mesh, takes an index and locates the new quad. So let's use that. Call add2meshArrays. Let's pass in the vertices, the UVs, and the triangles. Now for the index, pass in our calculated index. And now here we need the position. So for the position, we can just go to the grid and ask for the get world position of this given x and y. All right. For the rotation, we don't want any rotation, so let's leave it at 0. And now here we need the size of the quad, so let's calculate it up here. A vector 3 for the quad size, and the quad size is really just, let's make it a vector 3 of 1, 1, and multiply it by the grid and get the cell size. Right, just like that. And now finally we need the UV, and for now let's just leave it at 0, so all our quads should be completely black. Over here on awake we are creating our mesh. Then on this function we are creating the empty mesh arrays with a given width and height. Then we cycle through every single grid position, and we add a quad to our mesh arrays. So all that's left is to go down here and update our mesh. All right, that should do it. Let's test and see if we are correctly creating our black mesh. And yep, there it is. There's our grid mesh. We can pause in order to go and look into the wireframe. And let's hide the background so we can easily see it. And yep, there you go. There it is. We can easily see every quad of our grid mesh being instantiated. Awesome. However, you can also see an issue with the mesh. The quads are on the origin of each cell position instead of being right down the middle. So we need to shift them all by half of our cell size. So let's do that. It's very simple. Just in here we get the quad position and we just increase it by the quad size multiplied by 0.5. Okay, test again. And yep, there it is. And all of our quads now perfectly match with our underlying grid. Great. Okay, so now the visual is set up. However, if I click to modify it, you can see the underlying value changed, but the color didn't. So we need to update our visual when something changes. So over here in the grid code, you can see that right in here, there's a nice event. And as the name implies, this is fired right when some value on the grid changes. So there it is down here on the set value. You can see we set the value and then we fire this event. So we can easily go back into our visual, and when we receive the grid, let's simply subscribe to that event. So grid on grid value changed. Let's subscribe to that event, and when that event is fired, we simply update our heat map. And that should do it. Very simple, and this clearly shows you the power of events. So let's just add a debug.log to make sure our event is firing, just like this. Okay, let's see. Okay, here we are. Let's click and see if the event is fired. Click, and yep, there you go. Over here on the console, you can see the event's fired. Click here, and yep. Okay, awesome. So we are correctly capturing our onValue changed event. So now almost everything is set up. We just need to deal with the UV for the quads to match the underlying value. So again, here is the underlying texture. It's a simple texture with 64 pixels on the width and 1 on the height. Now we want the color shown to match the underlying value. So with a value of 0, we want to show the black pixel right on the left, and with a value of 100, we want to show the green pixel right on the right. So let's go to our code, and in here, inside our cycle, let's calculate the UV. In order to do that, first we need to know the underlying value. So go into the grid. In order to get the value, let's get the value on the current X and Y. All right, this is our grid value. Now again, the UV is always set with a normalized value. So in order to calculate that, we need to define the current by the maximum. So we get our float grid value normalized, and we essentially just take our grid value and we divide it by our maximum, by our grid heatmap max value. And these are two ends, so again, in order to make sure we don't get any mistakes, we need to convert one of them into a float. All right, so here we have our normalized value, and with this, we can now create our UV vector 2. So a vector 2 for the grid value UV, and it's simply going to be, on the X, we pass in the grid value normalized, and on the Y, it doesn't matter, so let's just put it at 0. So then here on this function, we have actually two UV fields. We have one on the lower left corner and one for the UV on the upper right corner. However, in this case, we just want to show pretty much a single pixel, so it doesn't matter. Let's just put the exact same one on both. So every single vector will show the exact same pixel. All right, so just like this, it should be working. Let's see. Okay, here we are, and everything is black. All right, now let's click. And there you go, that one went from black to a dark red. Now keep clicking and it starts becoming more yellow. As it reaches 50, it's pure yellow. Now keep clicking and it's now green, green, green. And yep, now it's at 100 pure green. All right, awesome. So as the value goes up, so does the color go from red to yellow to green. So now we can set and view values in our heat map. Now, in order to achieve a nice heat map, we should make sure that when we click, we apply more than just on a single grid position. So in this case, we would like, if this one is at 50, to also impact the ones around it. Okay, so let's make a function to add a value to our grid map along with a certain range. So let's go into our grid. Here we have our set values and get value functions. Now let's make a add value. We're going to receive a vector 3 for the world position. Then we're going to receive an int for the target value to add. And let's also receive an int for a range. So here let's start off very simple. First we get the X and Y. Now we just cycle through the entire range. And in here we want to add the value. However, right now we only have a function to set the value. So let's make another nice helper function. And this will be the add value. It takes an int for the X, int for the Y, and then int for the value. And here, in order to add, it's very simple. We just call getValue on the X and Y. That gives us our current value, so we increase it by our target value, and we put all this inside a set value. Okay, so there it is, a very nice simple function. It takes the current value and increases it by this amount. Okay, now we can go down here and use it. So we cycle through the entire range, and we call add value on this X, so origin X plus this X, and we add our value. All right, this should be working. Let's test it. So for that, let's go into our testing class. And in here, we were doing pretty much the same add value. However, instead of that, let's do the grid.addValue. We're going to use the version that has the range, so pass in the position. Let's put a value of 5 and a range of also 5. And up here, let's make our grid bigger, but with smaller nodes. All right, let's test this. Okay, here it is. Let's move all the way up here. Now let's click right in here. And there you go. We now have a bunch of cells with 5. And if we click again, and there you go, these ones that were in the middle, they increased by 5, so now they have 10. All right, so we have our nice heat map correctly working. However, the shape that we're using is a square, which isn't very nice. We want a diamond instead. So let's see how we're using the range. Over here on our grid, we're cycling through the X and Y, both going from 0 to the range. But instead of a square, we want a diamond. So let's first make a triangle, since a diamond is essentially just 4 triangles put together. So over here we are cycling through everything, except on the Y cycle, instead of going from 0 to the range, let's go 0 to the range minus the X. So this way, the bigger the X is, the lower the Y will go. Let's test. Okay, here we are. Let's go and click right down the middle. And there you go, we now have a very nice triangle with a edge size of 5. Alright, awesome. Now to make a diamond, all we need to do is mirror this triangle both left and down. So first let's mirror it to the left, so we also call add value. Except instead of adding on origin plus X, we add on origin minus X. Okay, click, and there you go, we added on the right and on the left side. However, you can also see that we doubled on the first line, so we need to ignore that. So in here we only do this if the X is not 0. And yep, there it is. Now we have a right and left triangle. Okay, great. Now for the lower side, we do pretty much the same thing. We do add value on the origin Y minus the Y. And the same thing on minus X and minus Y. So let's see. Okay, click, and there you go. Alright, the shape is correct. Now let's just ignore the zeros. So we only do the Y's if the Y is not 0. And on the minus X, let's again do just if the X is not 0. Okay, here we are. Now let's try right here down the middle and click. And there you go, we have our nice awesome grid. And by clicking, we add the value in a diamond pattern. And if we click again, you can see that we add the value where we already had some. So if I click in here, there you go. These that are in between, they also increase. So I can add various and the color all looks very nice. So let's try this out without our debug. So go into the grid and over here, just set the show debug into false. And there it is. Now we just see a giant black square. And if we click, yep, there you go. There's our nice heat map showing all our nice colors. So as we increase, it goes up. And now that one is green, red, and so on. Alright, awesome. Now our heat map is pretty much done. Let's just add one more thing. A version that takes a range, and then the value falls off as it gets towards the end of the range. So down here on the grid, we have this function. Alright, that looks great. However, now let's split the range into two different values. So we're going first to have a full value range. So this is a range where the entire full value is added. And then we also have an int for the total range. So when we go past the full value range, we are going to decrease the value until we reach the total range. Okay, so let's first calculate the amount we're going to lower the value once we go past the full value range. Okay, so we calculate the lower value amount by the difference between the total range and the full value range. Now over here in the cycle, we're going to cycle through the total range. Okay, so then here inside our cycle, let's first calculate where we are on the current radius. So an int for the radius is simply the x plus the y. Then let's also define the value amount that we're going to add. So let's call it the add value amount. And by default, we start off with the full value. Then we test if the radius is bigger than the full value range. If so, then we want to decrease the add value amount by the lower value amount. So we go into add value amount minus equals the lower value amount multiplied by how far we are from the total. So the radius minus our full value range. So as we get past the full value range and towards the total range, it will go down, down, down. So visually, as we approach the edge of our radius, we should be able to see the center in green and becoming more red towards the edges. And down here, instead of the value, we use the add value amount, which has been calculated. Alright, great. Down here, let's test it with a really big radius. So first on the value, let's put the full value to be 100. Then for the full value range, let's put something small, so like 5. And for the total range, let's put 40. So for the first 5 positions around where I click, it will have 100, and for the rest until it hits 40, it will constantly be going down. So we should be able to see a diamond pattern start with green in the center and become red towards the edges. Okay, so to test, let's make our grid a lot bigger. Okay, so here we are and everything is black, meaning all of our grid is at 0. And now let's click. And there you go, there's our awesome colored diamond pattern. And if I click somewhere else, like right here on the right, and the radius intersects, you'll be able to see. And yep, there you go, over here where they both intersect, you can see that both values are being added. So when I clicked here, the positions that include both diamonds also increase their underlying values. So here we are with the debug visuals enabled, and now we can see how the numbers change. So let's click in here, and there you go. You can see right down the middle, it's at 100, so it's full, and as we go towards the edge, you can see the number constantly going down. And then if I click here on the side, yep, you can see it goes down, but these have been merged by both diamonds. So click on various sizes, and there you go, you can see the heat map getting very nice. There it is, all our nice numbers. Awesome. Now just one final thing. Over here we have a pretty serious performance issue in our code that we can easily solve. Over here on the heat map visual, we are updating our heat map visual whenever this event is fired. And then here on the grid, when we are creating our diamond pattern, we are essentially calling add value a whole bunch of times. And every time we add, we are triggering that event. So every time we trigger, we are updating the mesh. So essentially when we place, we are updating our mesh about 100 times in a single frame. That is obviously very wasteful and causes your game to hang for quite a bit. So instead, let's only update at the end of each frame where the underlying grid did actually change. So let's go up here, make a private, a boolean, call it update mesh. And then we go down here when the grid value changes, instead of calling this directly, let's simply set the update mesh into true. And then we're going to have a private void late update. And in here we test if the update mesh is true, then we set it to false and we update our mesh. So just like that, no matter how many times this event is fired in the same frame, it will only update once at the end of that frame. And if this doesn't change, it doesn't update, so everything is great. All right, let's see. Okay, here we are, let's try and click, and there you go, everything still works, but now I can click multiple times and the game no longer hangs, since the underlying mesh is only being updated at most once per frame. Awesome! So here it is, our final heat map visualization and the underlying grid system. This can be used for just about anything you want. You can use it, for example, like in Battle Royale Tycoon for making an environment map. So as I place environment objects, the environment becomes better, which gets enjoyed. Environment objects all have a certain value and a certain radius, and when put together, they combine into better values. You could also use it as a secondary pathfinding map to tell units which areas should be avoided and which should be desirable. The pathfinding would avoid red areas and move towards green areas. So by now, I think you can see how grid maps and heat maps are extremely versatile and can be used in a multitude of situations. So think about how you can apply it to your game. As always, you can download the project files and utilities from unitycodemonkey.com. If you liked the video, subscribe to the channel for more Unity tutorials. Post any questions you have in the comments and I'll do my best to answer them. Alright, see you next time.